Hi! To understand rational functions is something that it's very difficult for some people because they try to do many steps but they don't try to understand the properties of the rational functions. So this video is for you to understand the properties of the rational functions. Okay? So I hope that you enjoy it. I hope that you get information because this information helps you to understand the way to graph and the way to find domain and the way to find everything here. So let's go with rational functions, the properties of rational functions. Okay? So the first deal is what is a rational function. A rational function is a division or a quotient between two polynomial functions. So you have two polynomial functions and you divide them, then you have the rational function. And the only thing you have to establish in the rational function is that the divisor q of x should be different than 0. Why different than 0? Because division by 0 is not defined, tends to infinity, gets problems. So that's why you have to define that the q of x should be different than 0. Okay? That's the first part. So let's go to the second part. The second part says, for a rational function in lowest terms, all the x values for which q of x equals 0 are the vertical asymptotes of the rational function. So we're going to do an example. Let's do an example. Let's say that the rational function is x to the third power over x to the fourth power minus 1. Okay, x to the third power minus 1 over x to the fourth power minus 1. So as you could see here, the rational function is not in lowest terms because you can factor the polynomials and then you can have the simplest form or the lowest terms. So we're going to simplify it by factoring. So this is a difference of cubes. So x minus 1 times x squared plus x plus 1 over, and this in lowest terms is x minus 1 times x plus 1 times x squared plus 1. Okay? So if you don't remember how to do this, you can check many videos about factoring. You can see my other videos of a minute of factoring to see how to factor the difference of cubes and the difference of squares. Okay? So now we have the factored form. We have common factors here, x minus 1. So dividing by common factors, this is the rational function in lowest terms. Okay? So it means that this is the rational function in lowest terms. It means that for q different than 0 here, we have an asymptote. So the first asymptote is just getting by setting x plus 1 equals 0. So we just need to solve for x equals minus 1. This is the first asymptote. So let's write it here. First asymptote. And the other asymptote, second asymptote should be the solution of x squared plus 1 equals 0. But as you could see, this is an imaginary solution. It's not a real solution. It's the root of negative 1. So we're not going to have a second asymptote, just one asymptote. So the asymptote of this function is x equals minus 1. Okay? In lowest terms, all the x values for which q of x equals 0 are the vertical asymptotes of the rational function. So this is the vertical asymptote of this rational function. Now we're going to see more information. If the rational function is proper, then the function has a horizontal asymptote at y equals 0. What does it mean that a function is proper? Rational function is proper if the degree of the numerator is less than the degree of the denominator. So as you could see here, degree of numerator is less than degree of denominator, it means that this is a proper rational function, so the horizontal asymptote is just y equals 0. Okay, that's it. We don't need to think anymore. If it's proper, just the horizontal asymptote is y equals 0. Okay, but what happens when the degree of numerator is greater than degree of denominator? So if the rational function is improper, then we have to apply long division to find a horizontal or oblique asymptote. Okay, so remember, when you apply long division, you're getting the quotient plus remainder over divisor. So let's say that we have any rational function of the form px over qx, okay, and the degree of p is greater than the degree of q. So if I divide them by long division, I should have something like calling d, no, the quotient of these two, or capital Q, the quotient, plus remainder over divisor. Okay, the divisor here is Q. So as we apply long division, or you can apply synthetic if it's Q's of the form x plus a. So if I apply long division, we have in the remainder that is a degree less than the degree of Q. So it means that capital Q of x is the asymptote. If capital Q of x is a number, we have a horizontal asymptote. If it's not a number but it's a linear function, we have an oblique asymptote. If it's not a linear function, it's quadratic, cubic, or any other, we don't have oblique or linear asymptotes. Okay? And we're going to see, when we graph functions, we're going to see how that works. Okay, so this is about improper fractions. So to sum up, for proper, 0, horizontal asymptote 0. For improper, divide to get quotient, that is the asymptote, and the part of the remainder, the asymptote is 0. That's it. And remember that in lowest terms, the asymptotes, the vertical asymptotes are given by the quotient different than 0, equals to 0. And that's it. So 2 things you need to ask right now if you're prepared to pass to the next step, that is graphing rational functions, is: do I know long division? Because you're going to use long division to find asymptotes. And the question, how to graph the functions, how to graph rational functions. If I found the asymptotes, I found the domain, then I need to find the range, then I need to find intercepts and all this stuff. But this is not part of this video, it's part of the other video. So far, ask yourself if you know long division. If you don't know long division, I ask you to check the video about division that I have on my YouTube, or any other video about long division, and how to graph rational functions will be part of another video. So, thanks for watching. I'm happy to be here. Send me comments, send me anything that helped me to improve the way to teach you. And thank you, see you, goodbye.